Hello, everybody. Today we are going to be talking about independent and dependent variables. And if you're thinking to yourself, that sounds like science, you're right, but it is also math. So let's talk about independent and dependent variables in math. But you are definitely going to see some overlap from science. So these two subjects are not totally separate from each other. There's actually a good amount of overlap. In math, when we are talking about the independent variable, at least in this point in eighth grade, then we are talking about the x values or the domain or the input. And we've talked about these words before when we're talking about functions, but that's what we're talking about. We're talking about something that we don't know, which is what a variable is. A variable is an unknown amount, and it's the x values. Think about all of the y equals mx plus b equations, everything with slope and y-intercepts. Think about those x's, that domain, that input. That's your independent variable. Okay. In math, there are a few tried and true ways to determine the independent variable. So if you are looking at an equation that has an x and a y in it, the x is the independent variable. All right? Or whatever variable is in its place, which I will show you an example of, but sometimes an equation will be written with two variables that aren't y or x, but one of them is in the place where y usually goes, and one of them is in the place where x usually goes. Wherever the x usually is, that's your independent variable, and we'll show you one like that. You can also use a couple other ways to determine what the independent variable is. A lot of the times in our word problems, it's whatever happened first. And then this last one is a science definition pretty much. It's whatever variable was manipulated. Now, if you were here in class, I would ask you what manipulated means. Feel free to answer at home. But basically, it means whatever was changed. So if a word problem is describing an experiment or something that the person is changing, that's going to be your independent variable. All right. Now, the opposite of that, of course, is the dependent variable. And it has lots of names as well that match up really well with independent. It's our y values, it's our range, and it's our output. And the ways to identify it are sort of just the opposite. So if you see traditional x and y in an equation, the y is going to be your dependent variable. It's also what depends on the independent variable, which seems maybe kind of obvious. But let's say we're talking about how many bags of Takis you buy and what the price is. Well, the price depends on how many bags you buy. So the price would be the dependent variable. If you know what the word depend means, that's going to be super helpful here. If not, just pay really close attention to the examples and make sure you ask for help or clarification if you need it. The more science-y definition is identify whatever is being measured. So sometimes, even in math, you can get an independent or dependent variable question that's describing an experiment. And whatever is being measured, like the height or the weight or the volume, whatever is being measured in the experiment, that's your dependent variable. It happens as a result of the first thing. Okay? So let's look at some examples that range from very mathy to a bit sciencey. All right? So this first one is very straightforward. It says identify the independent and dependent variable in the equation below. And this is just a matter of memorization. If you see an equation written out like this is slope-intercept form. The y is always going to be the dependent variable, and the x is always going to be the independent variable. If you see something written in this form, this is slope-intercept form. Remember, this number is the slope, this number is the y-intercept, but that y is your dependent, and this x is your independent. All right, that's best case scenario. That's like the easiest kind of test question that's going to show up for this. Now, the one over here on the right is like the next best case scenario, where it doesn't have a y, it doesn't have an x, but it does have a similar layout. So let's read it and talk about a couple different ways you can do this. The total cost, T, for frozen yogurt depends on the weight, W, in ounces. Freddy's frozen yogurt shop uses the equation below to determine the cost of each cup of yogurt. Now, there isn't an x and there isn't a y, but could we rewrite this equation to look more like the one on the left? Yeah, absolutely. In place of the t, we'd put a y. In place of the w, we'd put an x, and then that looks just like the formula on the left, or the equation on the left. Okay, but I can't write that my independent variable is x because technically this problem didn't have an x in it. What did it have in the x's place? It had a w. So my independent variable is w. And then I can't say that my dependent variable is y because technically there wasn't a y. What was in its place? The letter t. So t would be the dependent variable. Now, that's not the only way to do it. We can read the problem and we can figure out what happened first or what depended on what. Okay, so in this case, I'm going to write a note down here at the bottom. The cost, which was T, depends on the weight, which was W. Because if my yogurt, my frozen yogurt only weighs a little bit, then my cost is going to be lower. But if my frozen yogurt weighs a lot, then my cost is going to be higher. So since the cost depends on the weight, that's how I know that the cost is the dependent variable. But if you're given an equation, I would really just take it at that surface value, and you can check yourself using other methods, but don't get too hung up on any one thing. Now, these last two examples, these do not have an equation. This we have just got to go into. Let's go back and refresh our memory really quickly to see what kind of stuff we're going to be looking for. When we're looking for our independent variables, we're talking about what happened first. Oh no, I think I broke the computer. Okay, we're talking about what happened first or what was manipulated, what was changed. Okay, so if I'm in control of this problem, what did I change? When we're looking for our dependent, we're talking about what depends on the other or what are we measuring. Okay, so let's go back and let's have a look at these and let's try not to mess up the program anymore. All right, the first one, the situation says the time it takes to get to work and the speed of a car. So, if I'm thinking about, let's think about it from an experiment perspective. Let's say that the experiment is how fast I'm driving to work and how long it takes me to do that. What is the thing that I am manipulating? What is the thing that I am changing? Can I change time or can I change the speed of my car? And unless you are some kind of magical wizard, the answer is I can change the speed of the car. So the speed is the independent variable. And then what's the thing that I'm measuring? I'm measuring the time it takes to get to work. So the thing I'm manipulating is my speed, and then the thing that I'm measuring is the time. So speed is independent, time is dependent. And if I read this to myself, if time is dependent, let's see if that makes sense. The time it takes me to get to work depends on the speed of the car. Yeah, that makes sense. So I did this correctly. Let's look at the last one. Here we go. This one is pretty sciencey. It sounds like an experiment here. The amount of water a plant is given and the height of the plant. So, independent variable is the thing that is manipulated. It's the thing that I am changing, or whoever's in this problem is changing. So, am I changing the amount of water, or am I changing the height of the plant? Well, I'm not planet Earth. I don't have any magic powers. I can't change the plant height. I can't force it to grow. I can manipulate the amount of water. So that's going to be my independent variable. And then the dependent variable is what is measured after. And so that's going to be the height of the plant. And if I want to read this back to myself, starting with this dependent variable here, if I say the height of the plant depends on the amount of water, does that make sense? Yes, that makes sense. So that means height of the plant is dependent, amount of water is independent. I know this can get a little bit tricky, but you're going to see it in science, you're going to see it in math, we're going to put it all together. It's going to be beautiful. Great job, guys.